Welcome back to the deep dive. Today we're attempting something pretty ambitious.
I'd say so. It's something that, a lot of people try, and it can go sideways pretty fast.
Exactly. We are trying to build what you might call a grand unified theory of longevity.
A high-risk, high-reward endeavor for sure.
It is. Usually when we tackle a topic like longevity, we pick one lane, we'll do a deep dive on, say, intermittent fasting, or we'll look at one specific book on sleep hygiene.
Right. We stay focused. We drill down on one thing.
But today, we have this massive stack of sources in front of us. We've got clinical data, expert interviews, systematic reviews. It's an attempt to integrate everything.
And the range of experts is,
Yeah.
well, it's pretty wild. You have neuroscientists, metabolic experts, sleep researchers,
And a divorce attorney.
and divorce attorney, which I have to admit, when I first saw that, I thought it stuck out like a sore thumb.
Me too. I thought, what is a lawyer doing in a stack of research on cellular health?
But then you look at the actual data. You look at the mortality data on things like loneliness and high conflict relationships, and suddenly it fits perfectly. It's a key piece of the puzzle.
We will definitely get to the lawyer later, but first, let's set the premise for this whole deep dive. We're trying to distinguish between lifespan, just keeping the heart beating for as long as possible.
Right, just adding years.
And health span, which is living better. It's about vitality and function, not just duration. And I want to be really clear about our board of experts today.
Yeah.
We are not here to summarize the generic advice you've heard 1,000 times. We're not going to just say, eat your vegetables. We're looking at specific and, yes, sometimes complex biological mechanisms.
Exactly. We're trying to move way past the what and really get into the how. How exactly does the liver process fructose differently than glucose? How does muscle tissue actually pull sugar out of your blood?
We're looking for the levers, the things you can pull that actually move the needle on your physiology.
That's the goal.
Okay, so where do we start with something this big? I think we can start with the foundation, metabolic health.
Absolutely. If the engine isn't running right, it doesn't matter how great the paint job is. Nothing else matters.
And we have a ton of material here from Dr. Robert Lustig. He's a bit of a controversial figure in some circles.
He can be, yeah, because he is so aggressive about one specific molecule.
Sugar.
Sugar. Dr. Lustig is a pediatric endocrinologist. And his entire life's work, his whole thesis, it really boils down to this one maxim. And it sounds simple, but the science behind it is incredibly deep.
What is it?
Protect the liver, feed the gut.
Protect the liver, feed the gut. Okay, let's unpack that. When he says protect the liver, what is he primarily protecting it from?
He's protecting it from being poisoned. And the poison he's identified is sugar, specifically fructose.
Right. And he makes this comparison that I've always found, a little hyperbolic maybe. He compares sugar to alcohol.
Yeah.
He goes so far as to say they are metabolically almost identical. Now, come on. A can of soda isn't a can of beer.
See, that's what we all think. But it's not hyperbole. That's the really scary part. He isn't talking about the behavioral effect of getting drunk. He's talking about the cold, hard biochemistry that happens inside your liver cells.
Okay, so break that down for me. What's the difference?
All right. So when you consume glucose, thick bread, rice, potatoes, every single cell in your body can use it for energy. Your brain, your muscles, your heart. It's an equal opportunity fuel. The body loves it.
Got it. Universal fuel.
But fructose, that's the sweet molecule in table sugar and high fructose corn syrup, it's totally different. It is not an essential nutrient. There is no biochemical reaction in the human body that requires dietary fructose. None.
So we don't actually need it to live.
We don't need it at all. And here's the crucial part. Only one organ can metabolize it in any significant amount.
And that's your liver.
So if I drink, say, a big soda, that entire fructose load, it doesn't get spread out around the body. It just makes a beeline straight for the liver. It's like a targeted missile. It slams the liver all at once. And more specifically, it overloads the mitochondria, which are the tiny power plants inside your liver cells.
Okay.
When those mitochondria get overwhelmed by this flood of energy they can't use, they have no choice. They have to take that excess energy and turn it into fat. The process is called de novo lipogenesis.
Making new fat.
Literally making new fat from scratch. And this is key, that fat doesn't necessarily go to your hips or your belly at first. It stays right there, inside the liver. That is the genesis of non-alcoholic fatty liver disease.
Ah, and that's where the alcohol comparison comes in.
That's where it holds up perfectly. Alcohol does the exact same thing. It goes through a slightly different chemical pathway, but the end result is the same. mitochondrial overload, oxidative stress, and the creation of visceral fat inside the liver.
So when we see kids today with fatty liver disease, which, that used to be a disease for old alcoholics, is because the metabolic substrate, the sugar, is driving the exact same pathology as ethanol.
Precisely. Your liver doesn't care if the mitochondrial overload came from a six-pack of beer or a six-pack of soda. The damage, the inflammation, the insulin resistance that follows, it's the same. So rule number 1 in this grand unified protocol for longevity is to stop flooding the liver.
Okay, that's protect the liver. What about the second part of his maxim, feed the gut?
This is the antidote. This is the positive action you can take. You feed your gut microbiome with fiber.
But not all fiber is the same, right?
Yeah, not at all. We need to be specific here. When you eat, say, the fiber in broccoli or beans, you aren't really digesting it. Your gut bacteria are. They eat it. And when they metabolize that fiber, they produce these incredible compounds called short-chain fatty acids, or SCFAs.
Like butyrate. I've heard of that one.
Butyrate's the main one. And what butyrate does is, well, it's miraculous. It's the preferred fuel for the cells lining your colon. It keeps that gut lining strong and intact. It prevents inflammation. And it even signals back to the rest of the body to improve insulin sensitivity.
So you take out the toxin, the sugar, and you add in the repair mechanism, the fiber.
Remove the poison, add the antidote. It's that simple and that profound.
This brings us to a story from Lustig's work that I found. Well, I found it genuinely disturbing, but it seems absolutely critical to understanding the modern obesity epidemic. The story from St. Jude Children's Research Hospital.
This is the story that should fundamentally change how everyone thinks about willpower and personal responsibility when it comes to weight. It really challenges the eat less, move more mantra.
So set the scene. Who were these kids?
Dr. Lustig was treating children who had survived brain tumors, a miracle of modern medicine. But the surgery or the radiation they needed to save their lives had damaged a tiny part of their brain called the hypothalamus.
And the hypothalamus is kind of like the body's central thermostat for weight and energy, right?
It's the master control center. It reads all the hormonal signals from your fat cells, especially a hormone called leptin, to tell your brain, hey, we have enough energy stored, you can stop eating now, and you can burn some fat for fuel.
So these kids had a broken thermostat.
Completely smashed.
Yeah.
As a result, they developed something called hypothalamic obesity. They were gaining massive amounts of weight uncontrollably. And of course, the standard medical advice at the time was applied.
Let me guess. Restrict their calories.
Of course. It's all about calories in, calories out. That's the first law of thermodynamics, right?
That's what we're all told.
So they put these kids on 500-calorie-a-day diets.
500 calories.
Yes.
That is clinical starvation. That's a bagel and a small coffee.
It's nothing. It's an amount of food that should cause rapid weight loss in anyone. And yet, the kids kept gaining weight.
Okay, I have to play devil's advocate here because this seems to defy physics. Physics is physics. If you are not putting energy in, how can you possibly create mass? Where is the fat coming from?
And that is the exact question that proves the calories in, calories out model is incomplete, if not totally wrong. It's not just about the calories, it's about what the hormones are doing with those calories.
So what was happening with their hormones?
Because of the damage to their brain, these kids had massive unchecked insulin spikes every time they ate anything. Their insulin levels were through the roof.
And insulin's primary job is to store energy. It's the fat storage hormone.
It's a one-way valve for fat. Insulin pushes energy, specifically glucose and fat, into your fat cells, and then it locks the door. Crucially, it inhibits a process called lipolysis, which is the breakdown of fat to be used as fuel.
So the fat can get in, but it can't get out.
It's trapped. So picture this. The kid eats their meager 500-calorie meal. Because of their sky-high insulin, maybe 400 of those calories are immediately shoved into their fat cells and locked away.
Which leaves only 100 calories left for the rest of the body to run on, for the heart, the brain, the muscles, everything.
Exactly. The rest of the body, the cells and the muscles and organs, are literally starving. The child is lethargic and exhausted, not because they're lazy, but because they have no circulating energy available to them. They're biologically starving to death while simultaneously becoming obese.
That is utterly terrifying. It completely decouples the condition of obesity from the behavior of overeating.
It proves definitively that biochemistry drives behavior, not the other way around. So when Lustig treated them, he didn't put them in boot camp. He didn't scream at them to exercise more. He gave them a drug, an old drug called octreotide, to suppress their insulin secretion.
He treated the hormone, not the behavior, and once the insulin dropped.
A key turned in the lock, The fat cells opened up, the stored energy flooded back into their bloodstream. The kids started losing weight, of course. But what was more important, more telling, is they started moving.
They felt better. They had energy.
They had energy. One kid, who had been completely sedentary, spontaneously became the basketball team's manager running around the court. The activity was a symptom of a fixed metabolism, not the cause of the weight loss.
That's a massive, massive paradigm shift. If you fix the signaling, the behavior follows. The energy follows.
Well, it's all about the signals.
Well, speaking of signaling, we have to talk about the biggest story in medicine right now, the GLP-1 craze. Everyone is talking about Ozempic and Wegovy.
It's everywhere.
But one of our sources, Dave Asprey, argues that we can actually get a similar Ozempic-like effect without needing an injection.
Yeah, he calls this concept natural Ozempic. What he's really talking about is finding ways to naturally stimulate your body's own release of GLP-1.
And GLP-1, or glucagon-like peptide 1, that's the hormone that these drugs are mimicking, right? It's the one that tells your brain, I'm full.
Exactly. It's a powerful satiety hormone. It slows down gastric emptying, so you feel full longer, and it acts directly on the appetite centers in your brain.
So how do we trigger that without a needle? What's the protocol?
Asprey points to a very specific type of carbohydrate, resistant starch.
Okay, define that for us. I've heard the term, but it's a little fuzzy.
Resistant starch is basically a starch that, as the name implies, resists digestion in your small intestine. So it travels all the way down to your colon, your large intestine, completely intact.
What are some examples of foods that have it?
Things like green, unripe bananas are a classic example, plantains. But also, and this is the cool part, potatoes or rice that have been cooked and then completely cooled down. The cooling process changes the molecular structure of the starch and makes it resistant.
So leftover cold potatoes from the fridge are actually good for you in this context.
They're fantastic. Because when that resistant starch finally arrives in your colon, it doesn't get absorbed. It ferments. It becomes food for your gut bacteria.
Ah, so this is another way to feed the gut.
It's a perfect example. And it feeds very specific, beneficial bacterial strains. One in particular is called Akkermansia nucinifera. When Akkermansia and other good bugs feast on this resistant starch, one of the signals they send out tells the cells lining your gut to produce more GLP-1.
So you're basically hacking your microbiome to send the I'm full signal to your brain for you.
You've got it. You're using food as a signaling molecule to regulate your own appetite hormones rather than injecting a synthetic version.
And Asprey has a personal story here that sounds eerily familiar.
It does. He talks about how he's a 300-pound guy in his 20s, and he was doing everything right. He was working out for 90 minutes a day, 6 days a week, eating a low-calorie, low-fat diet, and not losing an ounce. In fact, he was still gaining weight.
Which sounds exactly like the St. Jude kids, a broken metabolism.
It's the same fundamental mechanism.
Yeah.
His hormonal signaling was completely broken, probably high insulin, high inflammation. He claims that the turning point for him was when he started focusing on his gut. By introducing resistant starch and other prebiotics, he claims he quadrupled the number of beneficial bacterial species in his gut.
And that fixed the signaling.
It fixed the signaling. He stopped having uncontrollable cravings. He stopped being hungry all the time. And he says the weight just fell off without him having to use brute force willpower.
So the big takeaway from this whole first segment from both Lustig and Asprey is pretty clear. Metabolic health is a signaling game, not a calorie counting game.
Absolutely. If your insulin is high, if your gut is inflamed, if your GLP-1 is low, willpower is basically useless.
You cannot out-willpower a broken biochemical signal.
You can't. The body always wins.
All right, let's move from the engine to the physical structure itself, the chassis. We're talking about muscle. And Dr. Gabrielle Lyon has this phrase that I think should be on a billboard everywhere.
I know the one you mean.
Muscle is the organ of longevity.
It's such a profound reframe of everything we've been taught. For 50 years, the fitness industry, the diet industry, has sold us on one idea: weight loss, shrink, get smaller, step on the scale and see a lower number.
Right, it's all about subtraction.
Dr. Lyon argues that we need to throw that idea out and focus on what she calls muscle-centric medicine. The goal isn't to lose weight, it's to build and maintain muscle.
Now, she's not talking about everyone needing to look like a competitive bodybuilder.
Not at all. This isn't about aesthetics. It's about muscle as a functional metabolic organ. It's about what muscle is actually doing for us on the inside every second of the day.
Okay, so what is it doing? How does it connect back to what we were just talking about with sugar and insulin?
It connects directly. Muscle is the primary site in your entire body for glucose disposal.
Glucose disposal.
Think of your muscles as a suitcase for sugar.
A suitcase. Okay, I like that analogy. Explain.
When you eat carbohydrates, they get broken down into glucose, which enters your bloodstream. That blood sugar needs to go somewhere quickly, otherwise it causes damage. The best place for it to go is into your muscle cells.
How does it get in?
Through these little doorways called GLUT4 transporters, the glucose enters the muscle and gets stored as glycogen, which is just a chain of glucose molecules ready to be used for fuel the next time you move.
So if I have more muscle mass...
You have a much bigger suitcase, you have more storage capacity, you have more of those GLUT4 transporters. You can eat a meal with carbs, and your muscles just soak up that sugar like a sponge, preventing a massive blood sugar spike.
And if I have low muscle mass, a condition she calls sarcopenia...
Then you have a tiny little carry-on bag. The sugar from your meal has nowhere to go. It spills over, stays in the blood, which triggers a huge insulin response. And what does insulin do with that excess sugar? It sends it to the liver to be turned into fat.
So building muscle is, in effect, building a powerful frontline defense system against insulin resistance and type 2 diabetes.
It's your metabolic sink. It's the most important place to put the energy you consume. Without it, you're in trouble.
No, she also links muscle to something that, well, it usually grabs the listener's attention. Sexual function. Specifically, for men, erectile dysfunction.
The data she presents here is pretty staggering. She cites that 40% of men have some form of ED by the time they're 40 years old. 40%.
That's a huge number. And the typical approach is just to treat the symptom, right? Take a blue pill.
Right. Take a vasodilator, a pill that forces the blood vessels to open up. But Dr. Lyon argues that this is missing the point entirely. The penis is, first and foremost, a vascular organ. Its function is a direct proxy for your overall cardiovascular and metabolic health.
It's the canary in the coal mine.
It's the ultimate canary in the coal mine. If the small, delicate arteries there aren't working properly, you can bet the bigger, more important arteries in your heart and brain aren't in great shape either.
So how does muscle mass play into this?
Muscle is an endocrine organ. When you contract your muscles, they release these signaling molecules called myokines. These myokines are powerfully anti-inflammatory. They travel throughout your body and improve what's called endothelial function.
The endothelium is the lining of the blood vessels.
Exactly. It's the thin layer of cells that controls whether your blood vessels constrict or dilate. Healthy muscle helps keep that lining healthy and responsive. So weak muscles often equals weak, unresponsive blood vessels.
So her research shows that muscle mass is an independent predictor of sexual function. It's not just about testosterone.
Correct. So if you want to fix ED for the long term, don't just reach for a pill. Go do some heavy squats. Go build your organ of longevity.
Okay, so we've established we need muscle. It's not optional. But how do we get it? This brings us to the eternal debate you hear in every gym. Cardio versus weights.
A great debate.
Dr. Scott Forbes and his team did a big systematic review on this, looking at all the data. What did they find?
Well, the findings are nuanced, as they usually are in science. If you look strictly at the number of calories burned during the exercise session itself, cardio wins. An hour on the treadmill will burn more calories than an hour of lifting weights with rests in between.
And that's why you see people spending hours and hours on the elliptical machine, thinking that's the key to fat loss.
Right. They're chasing that number on the screen.
Right.
But for overall health span, longevity, and what we call body recomposition, losing fat while keeping or gaining muscle, Forbes review points to concurrent training.
Doing both.
Doing both. That's the gold standard.
But I've heard the gym bros say this all the time. Cardio kills your gains. Is there any actual truth to that? Is there an interference effect?
There is a genuine molecular basis for that concern. It's not totally made up. At a very deep level, resistance training and endurance training activate opposing signaling pathways in the muscle.
Okay.
Resistance training strongly activates a pathway called mTOR, which is all about synthesis and growth, building new muscle protein. Cardio, on the other hand, activates a pathway called AMPK, which is more about energy efficiency, breaking things down, and building more mitochondria. In theory, they send opposing signals.
So if I go for a run right after I lift, am I basically turning off the muscle growth switch I just flipped on?
In theory, maybe a little. But Forbes' review of the data in actual humans shows that for 99% of the population, the interference effect is negligible. It's really only a concern for elite, world-class athletes who are pushing the absolute limits of human adaptation.
So for the average person just trying to get healthy, it's not something to worry about.
Not at all. In fact, the aerobic conditioning you get from cardio actually helps you recover faster between your lifting sets. You can do more work. So concurrent training is synergistic. It allows you to build that big sugar suitcase with the weights while also keeping the engine that runs the fuel, your cardiovascular system, efficient.
Got it. Now, Forbes also brings up a supplement that I feel has a serious PR problem, creatine.
Oh, definitely.
People hear creatine and they think of, high school football players trying to bulk up,
Oh.
getting bloated with water weight.
It's so much more than that.
Yeah.
It's probably the most studied and safest performance supplement on the planet, and its benefits go way beyond the gym. We understand its primary mechanism pretty well. It helps your muscles recycle ATP, which is the direct energy currency of the cell. More ATP recycling means you can lift another rep or two.
But Forbes highlights a newer mechanism, one that involves our fat cells, or adipocytes.
This is the really interesting part. Fat cells use creatine. I would have never guessed that.
They do. It turns out that fat cells have creatine transporters on their surface, just like muscle cells do. When you supplement with creatine and increase the amount in your system, it gets taken up by your fat cells.
And what does it do in there? It increases the mitochondrial respiration within the fat cell itself. You're essentially turning up the metabolic idle speed of your fat tissue.
Whoa. So it's not just helping you lift heavier weights to build muscle, it's also directly making your fat tissue more metabolically active.
Exactly. It's promoting what scientists call whole body energy expenditure. It's a genuine metabolic enhancer, not just a muscle volumizer. It helps on both sides of the equation.
That completely changes how I think about it. Okay, let's shift gears now. We've talked about the engine's fuel and the body's structure. Now let's talk about the control system. Hormones, fertility, and repair.
The software that runs the hardware.
Precisely. And we have a mix of stories here, from the deeply personal to the cautionary. Let's start with Dr. Mark Hyman and the story of the director of the film Fed Up.
This is a tragic story, but it has such a specific and powerful lesson about personalized medicine. This woman, the filmmaker, had suffered through multiple recurrent miscarriages. And then she had a truly devastating pregnancy where the baby was born with anencephaly.
Which is being born without a brain.
Essentially, yes.
Yeah.
A fatal neural tube defect. It's just heartbreaking.
And what would the standard medical explanation for something like that be?
Typically, doctors would write this off as just tragic bad luck, a random genetic lightning strike. Nothing you can do about it.
But Hyman dug deeper.
He looked at her biochemistry, he ran some tests that aren't always standard, and he found two key things. First, she had very high levels of an inflammatory marker called homocysteine. And second, and this was the key, she had a very common gene mutation known as the MTHFR gene mutation.
MTHFR. I hear that thrown around a lot in wellness circles. It sounds like an acronym for a swear word. What is the actual mechanism here? What does that gene do?
It's all about a fundamental biochemical process called methylation. Methylation is happening billions of times every second in your body. It's responsible for repairing your DNA, for detoxifying chemicals, for turning your genes on and off. It's absolutely critical.
And to do it, you need certain nutrients.
You do. The main one is folate, also known as vitamin B9.
Okay, but hang on. If she was trying to get pregnant and had been pregnant, she would have been taking prenatal vitamins. And those are absolutely loaded with folic acid, which is the same thing, right?
Ah, that is the catch. That's the whole point of the story. Folic acid is the synthetic, oxidized version of the vitamin. If you have that MTHFR gene mutation, and by the way, about 40% of the population has some version of it, your body has a very hard time converting that synthetic folic acid into the form your body actually needs, which is called methylfolate.
So she was taking the prenatal vitamins, she was swallowing the pills, but her cells were essentially starving for the active form of the nutrient.
Exactly. She was drowning in the synthetic vitamin, but deficient in the real thing. And one of the most important jobs of folate during fetal development is to properly close the neural tube, which becomes the brain and spinal cord. Because her body couldn't process the vitamin correctly, the neural tube didn't close.
And the fix for this was what?
It was almost laughably simple. He had her stop taking folic acid and start taking premethylated folate, the active form, bypassing her broken genetic enzyme completely.
And the result?
She went on to have a healthy, beautiful baby.
Wow. That's just a powerful reminder that standard of care advice, like take your prenatal vitamins, doesn't work for everyone if their individual genetic hardware can't run the software.
It's the ultimate case for personalized medicine. One person's medicine can be another person's problem.
Dr. Felice Gersh takes this same personalized approach to another major hormonal shift, menopause. And she has a very specific way of framing it. She calls menopause a hormone deficiency state.
I love that framing. She completely rejects the idea that menopause is just a natural phase of life that women should just suffer through. She sees it as the loss of a critical protective hormone and argues we should treat it as such.
We tend to think of estrogen as just a reproductive hormone for making babies, but she argues it's so much more than that.
So much more. It's really a master regulator of the immune system, vascular health, brain health, and especially the gut.
She uses this term I'd never heard before, inflammaging.
Yes, inflammation that is driven by aging, or in this case, by the hormonal changes of aging. And here's the mechanism she lays out, which is fascinating.
Go on.
Estrogen is critical for maintaining the tight junctions in your gut lining. Think of it as the mortar between the bricks of your gut wall. It keeps the barrier sealed and strong. When estrogen levels plummet during menopause, that mortar starts to crumble. The gut becomes permeable.
It becomes leaky gut.
Leaky gut, and what leaks out from the gut into the bloodstream.
A bacterial toxin.
Exactly.
Yeah.
Things like lipopolysaccharides, or LPS. These are highly inflammatory molecules from the cell walls of bacteria. They leak into the bloodstream, and your immune system goes on high alert and attacks them.
And that creates a state of chronic, low-grade systemic inflammation.
That's inflammaging. And that chronic inflammation is what goes on to damage blood vessels, leading to heart disease, damaged brain cells, leading to cognitive decline, and damaged joints, leading to arthritis. It all starts with the loss of estrogen in the gut.
Now, a lot of women are justifiably terrified of hormone replacement therapy, or HRT, because of the famous Women's Health Initiative study and the KEEP study that linked it to an increased risk of cancer and heart issues.
And Dr. Gersh is very, very firm on this point. She says those studies were flawed, and we've learned so much since then. The KEEP study, for example, failed to show cardiovascular benefits for two main reasons.
What were they?
First, they used oral estrogen, a pill. When you swallow an estrogen pill, it has to go through your liver first. This is called the first pass effect. And the liver metabolizes that oral estrogen into byproducts that increase clotting factors, which raises the risk of stroke and blood clots.
Okay, so the delivery method matters. What was the second reason?
The dose was simply too low. It wasn't a truly replacement dose. It wasn't enough to actually restore the protective benefits for the gut, the brain, and the blood vessels.
So what's her protocol? What's the right way to do it?
Her protocol is to use bioidentical estradiol, the same molecule your body makes, and to deliver it transdermally. That means a patch or a cream on the skin.
So it bypasses the liver.
It goes straight into the bloodstream, completely bypassing that dangerous first pass effect in the liver. Get all the protective benefits, sealing the gut, protecting the brain, without the increased clotting risk. It's all about the molecule you use and the delivery method.
That's a critical distinction. Okay, one last story in this segment. A cautionary tale about repair from JJ Virgin. She talks about preparing for surgery.
Yes. JJ's philosophy is to treat surgery like an athletic event. You wouldn't just show up to run a marathon without training for months. So why would you let someone cut you open without prepping your body for the trauma and for rapid healing?
Makes sense. But she made a pretty critical mistake during her own facelift. And it's a mistake that I think a lot of people in the biohacking world are prone to making.
The more is better fallacy. She was doing everything right according to the books. She was using peptides to support collagen, she had hyperbaric oxygen therapy scheduled, and she was taking high doses of omega-3s, fish oil, to lower inflammation.
And fish oil is good for you, right? We're always told to take more.
Usually, yes. It's very anti-inflammatory.
Sure.
But what is one of its other primary effects on the body?
It's a blood thinner.
It's a potent blood thinner. It prevents platelets from clotting together, which is the absolute last thing you want when a surgeon is about to make incisions in your face.
Oh, wow. I hadn't even thought of that.
And then, to make matters worse, after the surgery, she took an oxycodone for the pain, which she had a bad reaction to. It made her start vomiting violently.
No. Oh, no.
So now you have a perfect storm. You have thin blood that won't clot properly, and you are creating massive amounts of pressure in your head and face from the violent vomiting.
That sounds like a disaster.
It was. She developed a massive hematoma, a huge pooling of blood under the skin. She said she looked like a monster from a horror movie.
So the lesson here isn't don't take fish oil. The lesson is know the context, understand the interactions.
Exactly. Her advice now is to stop all blood thinners, fish oil, vitamin E, ginkgo biloba, at least 2 weeks before any scheduled surgery. She did recover, by the way. She used all her biohacking tools, the hyperbaric oxygen, red light therapy, to heal rapidly enough to be on stage giving a speech just 10 days later. but she definitely learned the hard way.
But a very hard lesson. Okay, let's move upstairs to the control center. Let's talk about brain health and mindset.
Yeah, headquarters.
And we have to start with this fascinating concept from the neuroscientist Dr. David Eagleman. He calls it cognitive reserve. And the central story here is an incredible study of nuns.
The religious orders study. This is a true landmark in the field of neuroscience. It's been going on for decades. Researchers followed hundreds of nuns, priests, and brothers from across the country. They did yearly cognitive tests on them, and when they passed away, the individuals donated their brains to science for autopsy.
And what did the autopsies find?
This is the part that sent shockwaves through the scientific community. They would open up the skull of a nun who, according to all her cognitive tests, had been sharp as a tack right up until the day she died. And they would find a brain that was physically devastated by Alzheimer's disease.
What do you mean by devastated?
I mean, riddled with the classic plaques and tangles, so much brain shrinkage and damage that by all biological standards, this woman should have been in a nursing home, non-functional, unable to recognize her own family.
She wasn't.
But she wasn't. While she was alive, she showed zero symptoms, no memory loss, no confusion. She was leading community meetings, debating scripture, managing the convent's finances, perfectly lucid.
How is that even possible? I don't understand. If the hardware is that broken, how does the software continue to run flawlessly?
That is the million-dollar question, and the answer is cognitive reserve.
So what is it exactly?
The theory is that because these nuns lived such a unique lifestyle, they lived in a rich community, they had constant social interaction, they had chores and a sense of purpose, and they were constantly learning and engaging in complex intellectual debates. They built millions upon millions of extra redundant synaptic connections in their brains.
So they built a stronger, more resilient brain network.
Think of it like a city's roadmap. A brain with low cognitive reserve, maybe someone who becomes isolated, stops learning, watches TV all day, has just one main highway to get from point A to point B. If Alzheimer's creates a roadblock on that highway, the signal can't get through. The thought dies.
And the nuns?
The nuns' brains had that highway, but they had also built a dozen side streets, back alleys, and underground tunnels. So when Alzheimer's blocked the main highway, their brain just automatically rerouted the signal down a side street. The thought still arrived at its destination, perfectly intact.
So the physical pathology of the disease was there, but the functional outcome symptoms never appeared.
Exactly. Their cognitive function bypassed the physical damage. And Eagleman's prescription for building this reserve is simple: novelty.
Not just doing Sudoku puzzles over and over.
No. The brain is efficient. If you do the same puzzle every day, it builds one pathway and gets really good at it, but that's it. You need to force it to build new infrastructure. Brush your teeth with your non-dominant hand. Take a completely different route to work. Try to learn a new language or a musical instrument.
So the message is that comfort and routine are the enemies of neuroplasticity. You have to constantly challenge the brain with things it's not good at.
Precisely. Discomfort is the price of admission for a resilient brain.
That's a great concept. We also have a very practical tool for decision-making from Daniel Pink. He calls it self-distancing.
This is such a great mental hack, especially for emotional or stressful decisions. When we're stressed out or afraid, our amygdala, the brain's fear center, basically floods the prefrontal cortex, the rational part of our brain. We can't think straight. We make bad, short-sighted decisions.
And self-distancing is a way to bypass that amygdala hijack.
It is. He tells this amazing story about Andy Grove, the legendary CEO of Intel, to illustrate it.
I love this story.
Back in the 1980s, Intel's entire business was memory chips. That was their identity. But they were getting absolutely crushed by lower-cost Japanese competitors. They were losing money hand over fist, and Grove was paralyzed with indecision. He had this deep emotional attachment to the memory business. It's what they had built the company on.
So what did he do? He couldn't make the call.
He was stuck. So one day, he sat down with his co-founder, Gordon Moore, and he asked this very strange hypothetical question. He said, if the board of directors fired us today and they brought in a brand new CEO, what would he do?
He took Andy Grove, the person with all the emotional baggage, out of the equation.
He created distance. And Gordon Moore looked at him and said, without a moment's hesitation, the new guy would get us out of the memory chip business.
And the clarity was immediate.
It was instant. Grove said it was like a light bulb went on. And he said, why don't we just walk out that door, come back in, and do it ourselves? And they did. They pivoted the entire company to focus on microprocessors, which was a tiny part of their business at the time.
And that decision made Intel one of the biggest and most important companies in the world.
It saved the company. And the technique is so simple. Pink says you can do it by referring to yourself in the third person. Instead of what should I do, ask what should your name do? Or, my favorite, ask what would I tell my best friend to do in this situation?
It instantly shifts your brain activity from the emotional limbic centers to the more rational prefrontal centers.
It's a biological hack for clear thinking.
Let's move on to segment 5. We're talking about restoration, sleep, and environment. Now, we all know we need to sleep. That's not news. But Dr. Matthew Walker, the sleep expert, gives us some really interesting nuance on how we can use movement and exercise to improve our sleep.
And it's not a one-size-fits-all approach. He analyzed data from over 1,300 participants to see which types of activity helped with which sleep problems.
And what did he find?
If your goal is to sleep longer, to increase your total sleep duration, the clear winner was yoga.
Yoga. Why yoga specifically?
The theory is that it's the best form of movement for activating the parasympathetic nervous system. That's the rest and digest side of your nervous system. It lowers cortisol, it reduces heart rate, it calms the mind down before bed, and the effect was huge. It added, on average, about 110 minutes to people's total sleep time.
An hour and 50 minutes. That's a massive effect.
It's life-changing. But if your problem isn't duration, but rather you have insomnia, you lie in bed and can't fall asleep, a different type of movement was better.
What was that?
Simple walking or jogging. The rhythmic, repetitive nature of it, combined with the rise and then fall in body temperature, seems to help reset the body's circadian drive for sleep. It significantly reduced the severity of insomnia symptoms.
So you tailor the movement to the sleep problem. That's great. Now, another source, Jack Delacio, brings up something that I will honestly admit I never ever think about, and that's the air quality in my bedroom.
We obsess over our mattresses, our pillows, the temperature, the blackout curtains. But we completely ignore the air we're breathing for 8 hours straight.
He focuses on two things, VOCs and EMFs. Let's start with VOCs. What are they and where do they come from?
VOC stands for volatile organic compound. These are chemicals that are off-gassing from everyday items in your room. The foam in your mattress, the paint on your walls, the glue in your carpet, the finish on your furniture.
And what's the problem with breathing these in while we sleep?
The problem is that they interfere with a critical brain cleaning process called the glymphatic system.
The glymphatic system, that's the brain's nighttime cleaning crew, right?
It's exactly that. It only really turns on when you are in deep, slow-wave sleep. Cerebrospinal fluid essentially washes through your brain tissue, flushing out metabolic waste products that have built up during the day. Things like amyloid beta plaques, the stuff associated with Alzheimer's.
And VOCs disrupt that process.
They add to the burden. If your body and brain are spending energy all night dealing with the oxidative stress from breathing in these low-level chemical toxins, it has fewer resources to dedicate to that deep cleaning process.
And he has some data on this.
He cites a study done with 75 professional athletes. All they did was install high-quality air filters in their bedrooms and manage the temperature properly. That's it. And they saw, on average, a 20 to 60% increase in their deep and REM sleep.
20 to 60% just from filtering the air. That is an unbelievable performance gain.
It's huge. And they also reported higher scores for happiness and focus the next day. Better air equals better brain cleaning equals better performance.
Okay, that's a powerful one. Now, for the people out there who simply can't get a perfect 8 hours every night, the new parents, the shift workers, the doctors on call, Dr. Gabrielle Lyon shared a protocol from another expert, Dr. Alison Breger, called sleep banking.
The idea of sleep banking is that you can, to some extent, preload on sleep. If you know you have a rough week coming up, you can sleep for 9 or 10 hours a night for a few days beforehand to build up a buffer and mitigate the performance decline.
But the real gem she shared was a specific napping protocol, the Green Beret tactical nap.
This one is so cool and so counterintuitive.
It involves drinking coffee right before you take a nap, which sounds completely insane. Explain the biochemistry of why that works.
Okay, to understand it, you have to understand a chemical in your brain called adenosine. As you go through your day, adenosine slowly builds up in your brain. The more that builds up, the sleepier you feel. It creates what's called sleep pressure.
And when you sleep at night, you clear all that adenosine out, so you wake up refreshed.
Exactly. Now, caffeine doesn't get rid of adenosine. All caffeine does is block the adenosine receptors. It's like parking your car in adenosine's favorite parking spot, so the adenosine molecule can't dock and make you feel tired.
Okay, I'm with you so far.
So here's the protocol. You drink a cup of coffee or take about 100 to 200 milligrams of caffeine. It takes about 20 to 25 minutes for that caffeine to be absorbed and reach your brain.
And in those 20 minutes,
You immediately take a 20-minute nap. That short nap is long enough to physically clear out a significant amount of the adenosine that's built up. Then, just as you're waking up, the caffeine arrives at the station.
so you wake up with less of the sleepiness chemical, the adenosine.
And at the same time, the caffeine arrives to block the receptors from any adenosine that's left. You get a double benefit.
So you bypass that groggy, foggy feeling you sometimes get after a nap, the sleep inertia.
You completely bypass it. You wake up feeling incredibly alert and refreshed. It's the perfect stack of a physiological process napping and a pharmacological one, caffeine.
I am 100% trying the Nappuccino this afternoon. Okay, final segment. This might be the most overlooked one. The social ecosystem.
The environment outside of our bodies.
And we promised a divorce attorney, and here he is, James Sexton.
And he brings this cold, hard, data-driven perspective from the front lines of relationship failure. He has a concept he calls the maintenance myth.
The idea that a good relationship, a good marriage, should just work on autopilot if you're with the right person.
Exactly. He sees these incredibly successful people in his office every day. High net worth individuals, CEOs, who run billion-dollar companies with exquisite minute-by-minute attention to every detail. But they treat their marriage like a crock pot.
Set it and forget it.
Set it and forget it. And then they're shocked when they come home and find it's either burned or cold.
Uh-huh.
And that's when they end up in his office.
He has a great quote about this.
He says, if you don't spend 10 minutes a week actively talking about the state of your relationship, you will eventually spend thousands of dollars an hour in my office.
But why is this a longevity issue? We're talking about health span.
Because loneliness and chronic relationship conflict are two of the most potent inflammatory stressors a human being can experience. It's a chronic, low-grade threat signal to your nervous system.
So it raises cortisol.
It raises cortisol, it increases blood pressure, it damages the heart over time. Studies show that people in high-conflict relationships have suppressed immune systems. They get sick more often.
So making the effort to send that text message, to write that note, to have that weekly check-in, it's not just a romantic gesture. It's a cardioprotective, immune-boosting act.
It's a deposit into your emotional reserve. It's a critical part of the health stack.
And finally, a therapist named Jerry Wise talks about family systems. This is really for people who have to deal with difficult or toxic family members.
His core concept is something he calls differentiation.
What does he mean by that?
It's the ability to be in the family system without being emotionally of it. It's about breaking the unhealthy emotional bond that makes you automatically react to their drama, their anxiety, or their narcissism. It's about being able to stay calm and regulated yourself, even when they are not.
And he links this directly to physical health in a very personal and very chilling way.
He does. He shares that his father died of a massive heart attack at the age of 35.
35? That's so young.
Incredibly young. And then Jerry himself had a significant heart event at the exact same age, 35. He realized he was on the exact same trajectory.
What did he attribute it to?
He attributed it to intergenerational anxiety. He realized that his own nervous system was completely entangled with and mirroring the chronic anxiety and stress of his family system. He was carrying their physiological burden.
And the solution for him was to differentiate.
He worked deliberately to regulate his own vagus nerve, to create an internal state of calm that was independent of his mother's mood or his father's anger. He broke the physiological cycle.
Yeah.
And he's still alive and well decades later.
That brings everything full circle, doesn't it? Longevity isn't just about the molecule you eat or the supplement you take. It's about the quality of the signals your body receives, whether that signal is insulin from a donut, cortisol from a toxic relationship, or a sense of safety from a healthy one.
It is the full stack, from the cell to the society.
So let's try to synthesize all of this. We have covered a huge amount of ground: the liver, the muscle, the hormones, the brain, the air we breathe, the families we come from. What is the one single thread that ties all of this together for you?
For me, the unifying concept is reserve. It's all about building a buffer.
Explain that.
The nuns from the study, they had built a massive cognitive reserve. The damage was there, but their buffer was so big it didn't matter. The person who does concurrent training is building physiological reserve, so their body can handle a big meal or a stressful day.
And the hormone therapy.
That's building hormonal reserve, protecting the organs from the decline of aging. The healthy relationships, that's building emotional reserve so that one bad day doesn't send you into a spiral. In every single domain, the goal is to build a buffer.
The wider your buffer, the more insults a virus, a stressful event, the simple act of aging you can absorb without breaking.
That is the definition of Healthspan, building the buffer.
Building the buffer, I love that. Okay, we have thrown a lot at you today. The Green Beret nap, the resistant starch in cold potatoes, the self-distancing question that saved Intel.
It's a lot to take in.
So my challenge to you, the listener, is just to pick one. Don't try to do everything tomorrow. Just pick one mechanism we talked about today.
Maybe tonight you go buy a good HEPA air filter for your bedroom. Maybe tomorrow you have some cooled rice with your lunch. Maybe you just take 2 minutes to ask, what would I tell my best friend to do about this problem?
Or maybe you just do 10 good push-ups to open up those GLUT4 channels in your muscles. Pick one thing.
And just start building the reserve.
Thanks for diving deep with us. Stay healthy.
Stay curious.